we have considered the destruction of worlds and the end of civilizations. But there is another perspective by which to measure human endeavors. Let me tell you a story about the beginning. Some 15 billion years ago, our universe began with the mightiest explosion of all time. The universe expanded, cooled, and darkened. Energy condensed into matter, mostly hydrogen atoms, and these atoms accumulated into vast clouds, rushing away from each other, that would one day become the galaxies. Within these galaxies, the first generation of stars was born, kindling the energy hidden in matter, flooding the cosmos with light. Hydrogen atoms had made suns and starlight. There were in those times no planets to receive the light, and no living creatures to admire the radiance of the heavens. But deep in the stellar furnaces, nuclear fusion was creating the heavier atoms, carbon and oxygen, silicon and iron. These elements, the ash left by hydrogen, were the raw materials from which planets and life would later arise. At first, the heavy elements were trapped in the hearts of the stars, but massive stars soon exhausted their fuel and in their death throes returned most of their substance back into space. The interstellar gas became enriched in heavy elements. In the Milky Way galaxy, the matter of the cosmos was recycled into new generations of stars, now rich in heavy atoms, a legacy from their stellar ancestors. And in the cold of interstellar space, great turbulent clouds were gathered by gravity and stirred by starlight. In their depths, the heavy atoms condensed into grains of rocky dust and ice and complex carbon-based molecules. In accordance with the laws of physics and chemistry, hydrogen atoms had brought forth the stuff of life. In other clouds, more massive aggregates of gas and dust formed later generations of stars. As new stars were formed, tiny condensations of matter accreted near them, inconspicuous motes of rock and metal, ice and gas that would become the planets. And on these worlds, as in interstellar clouds, organic molecules formed, made of atoms that had been cooked inside the stars. In the tide pools and oceans of many worlds, molecules were destroyed by sunlight and assembled by chemistry. One day, among these natural experiments, a molecule arose that quite by accident was able to make crude copies of itself. As time passed, self-replication became more accurate. Those molecules that copied better produced more copies. Natural selection was underway. Elaborate molecular machines had evolved. Slowly, imperceptibly, life had begun. Collectives of organic molecules evolved into one-celled organisms. These produced multi-celled colonies. Their various parts became specialized organs. Some colonies attached themselves to the sea floor. Others swam freely. Eyes evolved, and now the cosmos could see. Living things moved on to colonize the land. The reptiles held sway for a time, but they gave way to small, warm-blooded creatures with bigger brains who developed dexterity and curiosity about their environment. They learned to use tools and fire and language. Star stuff, the ash of stellar alchemy, had emerged into consciousness. We are a way for the cosmos to know itself. We are creatures of the cosmos and have always hungered to know our origins, to understand our connection with the universe. How did everything come to be? Every culture on the planet has devised its own response to the riddle posed by the universe. Every culture celebrates the cycles of life and nature. There are many different ways of being human. But an extraterrestrial visitor, examining the differences among human societies, would find those differences trivial compared to the similarities. We are one species. We are star stuff, harvesting starlight. Our lives, our past and our future, are tied to the sun, the moon, and the stars. Our ancestors knew that their survival depended on understanding the heavens. They built observatories and computers to predict the changing of the seasons by the motions in the skies. The discovery that there is order in the universe, that there are laws of nature, is the foundation on which science builds today. Science is a collective enterprise that embraces many cultures and spans the generations. In every age, and sometimes in the most unlikely places, there are those who wish with a great passion to understand the world. There is no way of knowing where the next discovery will come from. What dream of the mind's eye will remake the world? These dreams begin as impossibilities. Once, even to see a planet through a telescope was an astonishment, but we studied these worlds, we figured out how they moved in their orbits, and soon we were planning voyages of discovery beyond the Earth and sending robot explorers to the planets and the stars. We humans long to be connected with our origins, so we create rituals. Science is another way to express this longing. It also connects us with our origins, and it too has its rituals and its commandments. Its only sacred truth is that there are no sacred truths. All assumptions must be critically examined. Arguments from authority are worthless. Whatever is inconsistent with the facts, no matter how fond of it we are, must be discarded or revised. Science is not perfect. It's often misused. It's only a tool, but it's the best tool we have. Self-correcting, ever-changing, applicable to everything. With this tool, we vanquish the impossible. With the methods of science, we have begun to explore the cosmos. For the first time, scientific discoveries are widely accessible. Our machines, the products of our science, are now beyond the orbit of Saturn. A preliminary spacecraft reconnaissance has been made of 20 new worlds. We have learned to value careful observations, to respect the facts even when they are disquieting, when they seem to contradict conventional wisdom. We humans have seen the atoms which constitute all of matter, and the forces that sculpt this world and others. We have found that the molecules of life are easily formed under conditions common throughout the cosmos. We have mapped the molecular machines at the heart of life. We have discovered a microcosm in a drop of water. We have peered into the bloodstream and down on our stormy planet to see the Earth as a single organism. We have found volcanoes on other worlds and explosions on the sun, studied comets from the depths of space, traced their origins and destinies, listened to pulsars and searched for other civilizations. We humans have set foot on another world, in a place called the Sea of Tranquility, an astonishing achievement for creatures such as we, whose earliest footsteps, 3.5 million years old, are preserved in the volcanic ash of East Africa. These are some of the things that hydrogen atoms do, given 15 billion years of cosmic evolution. It has the sound of epic myth, but it's simply a description of the evolution of the cosmos as revealed by science in our time. And we who embody the local eyes and ears and thoughts and feelings of the cosmos, we've begun at last to wonder about our origins, star stuff, contemplating the stars, organized collections of 10 billion atoms, contemplating the evolution of matter, tracing that long path by which it arrived at consciousness here on the planet Earth and perhaps throughout the cosmos. Our loyalties are to the species and the planet. We speak for Earth. Our obligation to survive and flourish is owed not just to ourselves, but also to that cosmos, ancient and vast, from which we spring.